Welcome to 𝒕𝒓𝒅𝒄𝒂𝒏𝒕𝒅𝒄𝒂𝒏𝒕𝒅 Technologies. In this present video, we are going to learn how to interface the 𝒕𝒓𝒄6050 accelerometer gyro with this Arduino. So this is also another I2C device which is interfaced with the same serial bus, I2C bus. So only 4-wire interface, VCC ground and the serial clock and serial data. So these 4 pins are going to get connected to the cable here. So already there is a slot provided here which is mentioned as accelerometer. Remember this as well as this. These 3 are I2C devices with different addresses running on the same bus. So only with 2 wires Arduino is able to communicate with different devices. Now when we click on this MPU accelerometer gyro sketch, you are going to see a library called MPU6050 1.30 zip. So this is the zip library that is necessary for uploading the sketch here. So before you start uploading the sketch, once you try to install the library as mentioned in the previous examples, you go to sketch, include library, include zip library, and there you give the path for this particular file. Now the sketch is opening. So this sketch actually includes MPU6050.h header file. This I2C dev is not included, it's in comments, so it's not used here. Only I2C, MPU6050 and wire.h, these two are the libraries used here. And we have created an instance of MPU6050 as Accel gyro. This is basically accelerometer cum gyroscope. It gives you acceleration as well as gyroscopic values. 6 variables it is going to give, and its address is actually 69, 0x69. Earlier we saw 03C for I2C OLED and 0x27 for this 16:2 LCD. So different addresses are there. On same bus we are calling different devices, and we are creating a 16-bit integer for acceleration AX, X direction of acceleration, AY, Y direction, and AZ, Z direction. Similarly, the gyroscopic values GX, GY, and ZZ are also going to be printed with these variables. So hash define output readable accelerometer gyro. So if we set this flag, it is going to enable the output values of this accelerometer. Simple. In the setup we have serial.begin and wire.begin. Serial.begin is for printing the values, and wire.begin is for the I2C communication. As I said, if you are using either SPI or I2C, you need to use this wire.begin library. And then Accel gyro, this is the constructor which we have used earlier, dot initialize. So this is going to initialize the libraries, the registers of this particular accelerometer, and they are going to get printed in the loop function. So in the loop, this accelerometer gyro object get motion 6. So the 6 parameters of this motion, if you turn this accelerometer this way or that way, it is going to deliver 6 parameters every time. It is a MEMS based accelerometer, micro electromechanical devices, MEMS. So such a kind of devices are capable of sensing the acceleration and the tilt. So those values are going to be displayed under this function. And after we got this A and G, we are going to print them as AX, X component of acceleration, and then printed tab, and then Y component of acceleration, and then printed tab, and then AZ tab, and then GX, gyroscopic acceleration, GX, GY, ZZ, also in the same format. Just this is the simple sketch. And if you hit upload, of course make sure that you select the same board, processor and COM, and then hit upload. After successful upload, you need to open the serial plotter. So here you see serial monitor so far we have seen, but this time we are going to use serial plotter. It is going to give us in a graph format. So after successful upload, we will see even a little vibration on this accelerometer as a huge change in the graph values of this particular accelerometer. We are going to see it in a moment. Now it is compiling the code. Almost compiling came to end. The green status bar. Now it is going to get uploaded. And remember, whenever you are uploading, please make sure that your COM window is closed. If the COM port is open, then it will sometimes throw an error. And don't open this serial monitor, you go for serial plotter, that is tools, serial plotter. When you click on this, you see a graph of certain values. See, you see some values getting printed, and I'll give a blow on this. See, when I hit the table, the acceleration components are changing. Actually, this accelerometer is lying on the table, and whenever when I'm hitting it, see, the vibrations are sensed. Not only that, when I take it here, when I tilt it, you see, when I hold it like this, it is going to print. Let me hold it like this. It gets stabilized. The values are stabilized. Suddenly I change. See, the values are changing. So when I tilt it, the acceleration as well as the tilt, the gyroscopic acceleration are changing continuously. In this way, we can actually sense the orientation of this particular sensor, which is mostly used in smartphones and also in the hard disks. Thank you.